Good afternoon and good morning to those of you out west. Welcome to today's Ask Me Anything from the Construction Specifier and Kinetics Noise Control. My name is Farheen. I'm the Associate Editor for the Construction Specifier, and I'll be moderating today's presentation. First, I'd like to introduce our speaker, John Sofra. As Director of Sales North America for Kinetics Noise Control, John manages sales and marketing efforts for the North American industrial in-plant, environmental outdoor, and HVAC airflow silencing markets. He has served on numerous ASHRAE technical committees for acoustics and vibration and airflow ventilation, taught continuing education courses on ventilation and acoustics, and authored papers for the Institute of Noise Control Engineering, as well as articles for Air Movement Control Association. He has more than 35 years of experience in noise control and ventilation design. In this episode of Ask Me Anything, John will discuss products and systems to address data center noise concerns. He will dive into common noise control methods specific to data centers as a function of sound absorption, sound blocking, composite solutions including sound absorption and sound blocking, and methods of ventilation silencing. Some questions have already been submitted ahead of time, but we will also answer any questions which you submit live. To cover a few housekeeping items before we get started, if you have any questions that you wish to submit while following along to this session, please post them in the Q&A located at the bottom of your screen. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, only use the Q&A instead. If you're experiencing any technical difficulties, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help from there. Today's episode is also being recorded and will be available on the Construction Specifier's website in the near future. John, thank you so much for joining us today. Please take it away.
Thanks, Farheen. Appreciate the introduction, and I think everybody would be happy because with that introduction, it cut 5 minutes off my presentation. No, I'm just kidding. But we want to talk today about controlling data center noise. And when we look at a data center, many of you know what a data center is, but I kind of like to set the stage. And when you look at the most simplistic description of a data center, it's a giant building. It's a giant campus that has a lot of power, a lot of cooling, a lot of computers, servers, and a lot of security that operates 24 hours a day, 7 days a week. And because of this, you'll find out because there's a lot of power, it needs a lot of cooling. Because there's a lot of computers and servers that need to stay cool, we need to make sure that you have the power and the cooling. And then the security, of course, is utmost importance because it's everybody's data today. And we talk about data centers as the engines and brains of the internet. So with that beginning, let's dig into what we're going to talk about. Data centers right now can be located in many different places. They can be right in the city limits. They can be built somewhere in a more suburban, rural area. Some areas you can look at building them in far out regions or more desolate regions. But when you look at this, there's a lot of things that the data center companies look at to determine on where they're going to place this data center. And one of the things they look at is what kind of municipal power do we have? You'll find out they have backup generators, but they really want to work off a constant municipal power. And so they want to look at that infrastructure. Do we need to build such an infrastructure if it's in a more of a rural area, or can we tap into the municipality, close city regions and shoehorn in a data center? There's no right or wrong answer other than which one's going to be the most efficient to not interrupt any of your data. Another place that they look at is looking at, what kind of disasters have they had in the area over the last 10 years? Has there been a lot of tornadoes, earthquakes? Are there things we need, floods? Do we need to look at? So these are some of the things they look at as well. And then they also find out that instead of concentrating a lot of their data centers in one area of the country, which they may do, they're also going to do another territorial data center campus somewhere else in the country or in the world. In case one area goes down, they can switch quickly over to the other. Well, when they're doing all this, data centers and the data center growth that we're seeing, regardless of where they put it, whether they put it in a very heavily populated area or whether they put it in a rural area. And it's funny, in rural areas, we got to be concerned about data center noise too, because sometimes there's cattle Sometimes they won't produce milk. There's a lot of issues. And also in rural areas, it's even worse because people are used to very quiet ambient noise levels, especially during the night. So noise is a concern. And everybody agrees we need data centers, but we also agree that we got to quiet them down with acceptable limits, both indoors and outdoors. One of the pieces of equipment that makes a lot of noise at a data center can be air-cooled chillers. They can either be on a rooftop, which we see a lot, but sometimes they're on grade next to a building. And when you look at an air-cooled chiller like you see here, you'll see there's compressor noise at the bottom. We have all the compressors along the sides, and they make this whining, squealing noise. And then you look at the top upblast prop fans, which also make a mid to lower frequency noise or a broadband noise from mid to high frequency. And what you find out is if there is a noise problem outdoors, which these can run unattenuated, meaning no acoustic noise control, they can run anywhere between 98 to 102 dBA. Okay. Now, back up a little bit, a lot of property line noise ordinances are running about 60 dBA during the day and 55 dBA at night. So you can see at the equipment, we're running very, very much higher than those acceptable levels, but also usually a property line's a distance away. And we'll talk about all that. But we have to address both. Sometimes people will put wraps around the compressors and then wonder why there's still noise, and that's because there's noise due to the upblast fans on top of the units. So, so we have to look at the whole thing as a system. Another thing you're going to see at a lot of data centers are cooling towers. Usually they're induced draft cooling towers, which means they don't have a lot of external static pressure to overcome any potential static pressure of a silencer on the intake or discharge. So these are things that got to be looked at. And there's ways to control this noise, which we'll talk about. But once again, you got to look at the intake noise and the propeller upblast propeller noise. And it's a system. And these often run about 86 to 98 dBA in close proximity of the units. I put a little note down here that I think is kind of interesting is that, when we're talking about our homes, our own residential homes or apartments, you might be looking at a AC unit that's 3 to 5 tons, an air conditioning unit, 3 to 5 tons. Now, if you look at this particular one at a data center, each of these units is about 1,000 or 1,050 tons each. Now, of course, there's a lot of redundancy here because if one goes down, another one needs to hurry up and kick in place. But we're talking some big, big cooling. We can also look at air handling units. A lot of times they're either up on the roof or a lot of times they're next to a building where they're actually cooling the interior of the building. And both they have intake noise outside, bringing in that fresh air intake air, and then discharge noise within the building we got to look at. And sometimes these have condensers on them. So we have to look at that too for the outdoor noise. And they run about 98 to 102 dBA. Now, interior, we said we want to run on municipal power. That's really where it's at. We really want to rely on municipal power in data centers. But at times there's outages. And so now we have to look at some kind of backup power. And a lot of times we're looking at diesel generators. Got diesel generators in the generator rooms. You're looking at casing radiated noise off the generator engine itself. You're looking at the cooling fan here that's going to make noise. And also that cooling fan is probably going to discharge air straight out of the building into the page or upwards. And we have to quiet that path down so people outdoors don't hear. And then the engine exhaust noise itself, like an engine exhaust on your car or on your diesel driven truck. We have to look at mufflers there. And these typically in the generator rooms themselves, the diesel generators running at full power can be anywhere between 100 to 110 dBA. Normal speech is at 60 dBA. So we're almost double that. And it's very interferent. There's a huge interference there. Also interiors, we're going to be looking at 85 dBA. Usually OSHA is going to say you can have a time-weighted average of 85 dBA, work over a period of 8 hours with no PPE or hearing protection. And otherwise, you can have some hearing damage. So, when you're looking at the generator rooms at 110, you're definitely going to have hearing damage without PPE or noise protection or some kind of noise control within the space. When we look at indoor noise, like the data center hall, it's hard when you have excess noise levels interior, especially when we're talking indoors, and it's hard to concentrate, communicate between people. And so, one of the comments are, if you have to shout to somebody 3 feet away from you, or you feel you have to raise your voice to somebody 3 feet away from you, you're more than likely running higher than 85 dBA. And now we talk about hearing conservation programs and things like that, and added cost over time. But this chart I found here is of a data center hall, and it shows that in a data center hall itself, you got the servers, you got the computers, you got the raised floor, the cooling, and the crack units, and all that. And you have power supply fans themselves, which tend to be some of the most noise in these spaces. And a data center hall runs about 80 dBA. A vacuum cleaner, a normal vacuum cleaner in your house is 75 dBA. Alarm clock's 80 dBA. Conversational, normal conversation is 60 dBA. So you can see between 80 and 60, we do have some issues internally that we need to quiet things down. Now, when you look at different noise control products and their successful applications, there's a lot of different products you can use in industry. It isn't that and it's great that there's a lot of products. That's not the challenge. It isn't a challenge of finding the right product. It's making sure you understand how to use that product and why is it the best product for your application. I put together a chart here that talks about noise control products and applications. And, I have the different areas that we talked about here. A lot of people ask after a presentation, well, can I use that product in this space? Well, what we wanted to do here was let's start with the space. Let's start with listing spaces for you. And you can say, oh, look, yeah, they can use it in my generator room internally, or my generator yard next to the building outdoors, or my cooling plant outdoors, or my pump room indoors, or my centripetal UPS room, or my main data center floor. So when we look at that, there's a couple different things we can do. We can absorb sound within a reasonable limit. Like you might be in a room, let's say there's a lot of noise, you're running and with absorption alone, by putting absorption on the walls and the ceiling, you're going to max out at about a 10 dBA reduction, maybe a 12 dBA reduction for a normal size room. But you're saying that's not quiet enough. So remembering too that a 10 dBA reduction, because it's logarithmic, remember this, if you're running at 90 dBA and you reduce the noise levels to 80 dBA, or a change in 10 dBA, doesn't sound like a lot, right? But the way dBA works and the way it was developed, the average human's gonna perceive that 10 dBA noise reduction as sounding half as loud. So that's significant. Half as loud, that's huge. Wow, 90 dBA to 80 dBA, 80 dBA is going to sound half as loud. Whether that's quiet enough for your application, that's another story, but it is significant, your perception of it. We can look at noise block walls outdoors. We can use either in generator rooms or cooling plant yards, or generator yards, acoustic louvers where we have to vent maybe a generator room, a pump room, or a cooling plant piece of equipment. Vent silencers can be used either on the main data center floor, where you might have a crack unit sitting above a raised floor and the cool air is being pushed under the raised floor. That air might make a little noise, and you can actually mount, besides vibration isolating with a special base that Kinetics does for those crack units, because vibration's the enemy to data centers. You can also put a built-in silencer, scoop silencer in there to quiet that noise discharging below the floor, and quieting all that down before it can propagate up through the floor registers. And then noise block stacks are something we'll show you that go on top of an air-cooled chiller. It's really cool. It's to control that upblast noise. It's really neat. And one thing that we should note right now is that all the products we're going to cover, because this is very important, right, is fire ratings. They're all Class A fire rated or better. In other words, the reason I say or better, Class A allows a flame spread max of 25 and a smoke developed max of 450. But some of these products you're going to find have a flame spread of maybe 10 and a smoke developed of only 50 or less. So we say Class A, all these products are at least Class A or better. So I want to let you know that. That's very important. One of the products we can look at, and this is actually here as a generator room. This is kind of a distribution area. This is also another area that was entering into a server space. It's really neat. And we have some of this mid to high frequency noise, especially in the center picture and this side picture. So what we do is we have a product called S4 panel absorber. It has an NRC of 0.94. The best NRC, the perfect absorber, is an NRC of 1.0. So this is going to absorb very well. It comes in various thicknesses. Now, due to the way the ASTM standard C423 for sound absorption rates things, the numbers don't always work out, meaning that even though the best absorber you can get is an NRC of 1, noise reduction coefficient of 1.0, you will see some values as they calculate out at like 1.1, 1.2 for an NRC value. But really, using 1 in your brain is the perfect absorber. So these are really good. They're going to absorb reverberant sound very well, that echoey sound. Remember, sound is energy. We want to reduce those energy levels by absorbing it into something like an S4 panel, which we'll talk about in a minute. But it comes in white, it comes in silver. Silver, I personally don't like so much, but some people like them. This is actually a generator room where they line the ceilings and the walls with 4-inch versions of this. Up here is running it into these trusses, and over here is stick pinning it to the walls and the ceiling. There's also different ways to mount it. But if you look here and I blow this up, you'll see, well, how is this floating up there? Because it's only 3-pound board, 3-pound per cubic foot board. So it's stiff, but not stiff enough to span, these are 4 wide by 8 long butted together. So as we look at that, you kind of see these little straps in here. And those straps, then they're aluminum straps. And I'm just trying to highlight it because you never get a great picture at a job site when you want to blow it up. So it's a little blurry, but it shows these aluminum straps, which are really light gauge, light thickness aluminum, very light straps. And then you can attach those to the structure and then basically trapeze and you can see there's other ones in here, trapeze those panels. Now those panels, one thing you look at is you look at an initial cost. The initial cost of those S4 panels is awesome. It's a low cost. It's very cost effective. They're fire rated and easy to install. But I think that's the big thing is that you have an initial cost, but well, wait, I forgot I have an install cost too. But what you're going to find on all these products you're going to look at, installation is what we call low installation costs or simplistic installations. All right. So this one can either be stick pinned. These can be 2 or 4-inch thick or 1-inch thick panels that can be 4 foot wide by 8 foot tall or various custom sizes. They can also be then clipped onto the walls or mounted with these where if you say, I don't want any stick pins or penetrations in the panel. Another one is the PET, the polyethylene terephthalate. It's recycled. Think of it this way. Think of all your water bottles and they throw them in this machine and it shreds the heck out of them. This is really recycled plastics and things like that. And one of them are your water bottles. And it comes in various colors, but often you're going to be looking at black, this charcoal gray, which seems to be great in manufacturing facilities because black makes it too dark. This is a really good color to use, and it comes in white, but people don't like white because no matter how clean things are, they're going to show dirt over time. So these are really nice to come in 1 or 2-inch, or you can double layer them up to 4-inch thicknesses. You can buy you can have them factory cut or buy hundreds of 4 by 8 foot panels and field cut them to fit. Stick pin once again, real good absorption values. So basically you're using different types of impaling pins, stick pins, some mastic on the back. It's a great, easy field install, but we're doing this to reduce the noise within the space. Could be a pump room, could be a generator room. Remember, we're going to max out at about 10 dBA, maybe 12 dBA reduction. Remembering 10 dBA is going to sound half as loud, might not be quiet enough, but it's going to be perceived as sounding half as loud. And this is the absorption side of things, the reverberant side of echoing in spaces. Another one is a curtain, Kinetics curtain product, which is a quilted absorber. We actually take 2 layers of aluminized face, vinyl impregnated cloth, and then we put an insulation in the center of it. We stitch it all up, seal it all up, put factory grommets in here. These are actually 4 foot tall, 20 foot long, and we just layer them. They're not even attached to the wall. They're just hanging in here. And what it was the space below is too congested. It's too congested to put enclosures or barriers or just the workflow's too busy. So they only had to drop 8 dBA. So we do a reverberation analysis and we determine how much of this absorber would be needed on the walls and if any on the ceilings. So it's a great product, low cost product to use. Another one are these are called wave baffles. You kind of look at them, they kind of look like little waves. Now they come in other colors, not blue because they're called wave baffles. They come in other colors. But this is a generator room here. This happened to be at a power plant, this picture. However, these could be used in a generator room at a data center. Another one are these hanging baffles that are 4 foot tall and 8 foot long. They can be hung. They're also FDA approved. If you need them somewhere in a space like that, it just doesn't have to be a data center. You can get an FDA Tyvek bagging and use it. In fact, some places we use it in food processing. We also, what's nice with these is you can avoid lights. You can put these in a space. You can avoid sprinkler systems. The key is we want to reduce that reverberation noise, the energy buildup within the space by softening. Instead of hard walls and live space, which is very reflective, we want to soften that space, soften those walls. And you can see here, very simple to install. This one, if it's perpendicular to the I-beams, you got suspension cables for those. This one actually is a 2 foot tall by 4 foot long hanging baffle. You can come in different arrays. We can help you figure that out and determine your noise reduction before you even buy it. That's the key too, is to give you working with the acoustical consultant, working with your team internally, however you want to do it, but so you know what you should anticipate for your noise reduction before you purchase anything. Outdoors, we use a rigid version of this. These can be aluminum perforated panels. You can't tell here, but they actually have little 1/8-inch holes in there on 3/32 centers, this perforated material. It can be flush mounted at a wall like here, or it can be offset maybe 1 or 2 inches. And it basically, these are, the one on the right is an outdoor equipment yard with a bunch of air-cooled chillers in it. The neighbors were complaining. The noise was bouncing off those concrete cinder block walls, and we wanted to soften them up. The architect had planned on this early in construction phase, so actually budgeted in monies and was able to go the more expensive route with these, or the more well, expensive because they're metal and aluminum powder coated panels, and they were able to soften the space. You can see here, very easy installation. Everything comes powder coated. Insulating media could be used outdoors or indoors. That's a good question. Can these be used outdoors and indoors? Every product can be used indoors or outdoors, but some have a different version of the product, so it can withstand UV light and weathering. Now, if you look at this, outdoors, we have a lot of things that happen, and it's these air-cooled chillers. We talked about this early on in this presentation as a noisemaker. We have the air-cooled chillers, and what happens here is that those upblast fans make a lot of noise. And you can see here, in many times a data center, you're going to have neighbors when it's in a suburban area or in the metro area. You're going to have neighbors pretty close, and they don't want to hear these air-cooled chillers. A lot of times air-cooled chillers like to make ice and cool in the middle of the night, and that's when it should be the quietest outdoors. So people don't like this. They don't want to hear it. So as we address the compressors down here with one of our products, we actually design these freestanding. These do not attach to the chiller. We don't touch the chiller. Chillers aren't made to take into any kind of wind forces or anything like that, or the weight itself of this. But we pair off each of these fans, and we can vary through our calculations based on how much noise control you need, vary the height of these stacks. We do all the structural analysis inside. And so when somebody comes out and says there's nothing you can do because it's an air-cooled chiller, there is. Kinetics has worked with many of the air-cooled chiller manufacturers around the world for many years now, and the key is low pressure drop and don't touch my unit, and that's what we have for you. And some customers, there is an option to put access doors on the side here, so if a fan goes, because this might be only 2 feet tall, this solid part here, hopefully you can see my cursor, might be 5 feet tall. Sometimes if you got to pull one of those fans because one might have failed, they can either ladder up in or hoist in or bucket in, or they can have an access door on the side. This kind of shows everything from a side view with those parallel baffles. You can see nothing touches. Those parallel baffles stop just before, right here, these dotted lines stop just before the upblast fans or the unit itself. Another product are barrier walls. A lot of times at data centers where they used to be able on the rooftop, you have vision screens. So you have vision screens on rooftops of buildings. You see them all over. It could be a hospital, it could be a library. In fact, what we're talking about today, it often is a data center, and they want to hide all that rooftop mechanical equipment. So they use a single skin, non-acoustic, what we would call a vision screen. It's a pretty screen, maybe corrugated, looks nice, painted nice. But it has really no real acoustic noise control. And what we're starting to do is replacing those non-acoustic vision screens with our noise block acoustic panels. And that is very important. It may not need all of them, like maybe there's a rooftop data center rooftop system, and they want a vision screen that might be 600 feet on two legs and 150 feet on the other two legs, and they're very long, but they only need to replace all, or sometimes only part of that with our noise block panels. And you can see here it has insulating media, which is suited for outdoors and get wet, dry, freeze thaw, no problem. You have solid outer shells. They can be aluminum or galvanneal. Often we ship them painted, factory painted, because that's what they want. Paint can be matched, powder coat matched or wet painted matched for outdoor architectural exposure. We do all the structural engineering on staff. So we're able to either attach to the third-party structure, such as this case. There might be third-party structural steel because they were already designing the structural steel for the vision screens, the non-acoustic vision screens. Well, we have ways to adapt where their structural steel will be fine. But before we determine that, Kinetics will design all the reaction forces of all our attachment points to the third-party structural steel. So then the engineer of record can determine, based on moment forces, based on local IBC wind code driven or dictated wind forces and codes, then the engineer of record can determine whether their existing structure can support our noise block panels. So we work with the engineers. It's all a partnership. It's working together. Structural engineers talking to structural engineers, acoustical engineers talking to acoustical consultants, or data center engineers talking to all of us. And this is a great example here where we had one where it wasn't strong enough. So they actually had to add some kicker, what we call knee braces or kickers, to their existing steel in the field. What's really cool here is this is what we were calling the flush mount right here. This is flush mount. In other words, once you mount it, you don't see the structural steel behind it. And what's really cool here is this is a perfect picture. It shows all the noise block panels, 4-inch thick. They're all great. They're getting installed. The door hasn't been installed yet, the acoustic door. But you can see where it's flush mounted or surface mounted to the tube steel behind it. So people that look from the front don't see that tube steel. Same thing here. You don't see the tube steel. Now, another way to do it, though, sometimes an architect likes where Kinetics designs everything from base plate upward. We design all the base plates, the W columns or HSS tube steel columns. We design the panels. Everything's bolt together. Everything's factory. Everything's designed per local IBC. And sometimes architects like to look. This is actually a data center here that just got installed about 2 months ago. This is a parapet. I think it's like 42-inch parapet here of just some architectural facing around that parapet. But then behind that, down below behind it, and all the way to the top is a 12-foot tall barrier wall, freestanding barrier wall system. And you can see the vertical columns with the powder coated flashing. You can see the horizontal panels, the cap flashing. That was the look the architect wanted. Same thing here. We can do a coifred top. We really don't like to do those, meaning they cost a little more than the acoustical noise control they deliver. However, when you're in something like this, where you have a large building, a rooftop equipment yard, and you have apartments and balconies this close, we needed to control that line of sight. So we used a coifred type ceiling. Acoustic louvers, another huge thing, is many models. They can all be tuned. Kinetics has the most acoustic louver models out there. We range anywhere from these louvers being no through line of sight. It's a V-shaped air passage, or what we call a straight air passage, one that has more blades versus fewer blades, depending on, we call this one more of an industrial look, this more like an architectural look. And then we have our airfoil blade louver, which Really helps pressure drop wise, a little more expensive, but a lot of times is used because of the architectural look of it. These can be anywhere between 4, 6, 12, 16, 18, and 24-inch deep. So they can be tuned for many, many different things. On a data center, you're seeing the generator room holes plugged for the fresh air intake and the discharge, the mechanical room holes in the building plugged on the fresh air intake and discharge. This is really controlling. This is a huge environmental outdoor noise control product. And you can see here, this is a central utility plant. Each one of these are 14.5-foot square. You can see these are actually 24-inch deep, no through line of sight acoustic louvers. There's actually 1, 2, 3, 4 louvers here that are banked in the field. We have another one. This is no roof on this one. Has a roof. This one doesn't have a roof. This is a cooling tower yard. And then over here, an architect liked it. Instead of the noise block panels that you see on the roof, we talked about replacing those vision screen non-acoustic panels. Well, a lot of times architects like this, both for cross ventilation, if they have equipment close to the wall on the roof, mechanical equipment, or sometimes they just like it because of the look. So we can design these to match similar STC levels as our noise block panels, or sometimes you don't need as much, and we can design those in Kinetics to help you, the architect, the owner, and any of you engineers and consultants pick the right louvers for that. You can just see here, not going into it too much, but these are actually data center openings. Many openings in a data center. This is 202 inches tall by 176 inches wide. These are 2 foot deep, no through line of sight. And they have each one of these are look to be about 67 inches tall and 44 inches wide. They stack them up in the field. The big thing here is these louvers, because we have so many and we can tune them, we're balancing back pressure and we're against acoustics. And that's what we're always doing. And because we have so many models and versions, we can do that very, very well. It's not something either that the architect, acoustical consultant, or anybody or factory engineer or design build needs to pick on their own. We're here to help you walk through all that and lay in the right product. These can be surface mounted as we talk. This is kind of neat here. It shows the louver here, and you can kind of see the surface mount there at the top. And these are all factory made and powder coated and designed. Another thing is ventilation silencers. What happens a lot of times retrofit, because we're talking new construction, but we do a lot of retrofit data center work as well. And this particular one was a financial institution, data center. Neighbors were complaining about 1,500 feet away. And we were out there with the acoustical consultant at 4 a.m, firing up the generators, went through, determined which acoustic silencers were needed. These are all stacked up little banks of silencers, stacked up little modules, of silencers. These were actually 7 feet long. You can't see the whole thing. You're only seeing about 5 feet, 2 feet stuck into the wall. You can see the motorized dampers applied afterwards. And then on the outside, it typically looks like this. There's thousands of models to choose from. Everything's independently tested. You can see here kind of how the banks go together and what the silencer itself would look like. And then round silencers, a lot of times there's general exhaust on the building. Sometimes these can be 52, 58, 60-inch diameter general building ventilation. And the neighbors are complaining. You get all these points. You might have 20, 30, 40 of these on a roof. And you start getting a lot of noise to the neighbors, just enough for them to hear either a pure tone or a broadband noise frequency. And so we design the silencers to match that. We can even design a silencer, this silencer internal does not look like this round internal here, which we call a sound absorbing bullet. It doesn't look like that. It actually looks rectangular because there's a backdraft damper in here. When the damper opens, it basically aligns with the baffle, so there's basically no more real pressure drop than there would be for just a single wall piece of duct. So with that, that was a lot to go over, guys. We have different versions of this presentation that go up to 3 hours. There's a 1 hour, and this one we wanted to make sure we had time for questions. So I wanted to move that along, and this is where we're at. My name's John Sofra. I've been in business I've been in the industry, ventilation and acoustics industry, for 35 years. I love it. We like helping clients. We like working as partners. That's the biggest thing, is you don't have to be the expert. Let us help you. You're the expert on how your processes work, and that's where we come together. So we have three different email addresses. One's industrial for an implant noise control. You can send to that. That is monitored by a number of people internally. Environmental outdoor noise, commercial ventilation noise through duct systems. And then we also work through independent reps and licensees around the world. So that's where we're at. I'll leave it up to you, Fareen.
Awesome. Thank you so much, John, for that excellent presentation. That was wonderful. Now we'll move on to the Q&A. As mentioned, we do have some submitted questions that we'll ask first, but we'll also take on any questions you want to submit during the course of this episode. So just be sure to post them in the Q&A located below. First submitted question is, how do you reduce radiated noise from HVAC fan-powered boxes?
Oh, that's a really good question, and that's actually a product we kind of touched on, but we didn't. There's a version of that product, and we're going to talk about those jackets, those quilt jackets. We saw the ones on the factory walls that were just quilt; they were just for absorption. But we have a product that's a composite product. We call it composite because it does two things: it absorbs sound as well as blocks sound. And the great thing on there is somebody would send us that fan powered box, which a lot of times the fan power box they used to be above a drop ceiling, and they're one of the last things right before the air gets into a conditioned space like an office. And so, but now there's a lot of exposed ductwork in spaces, especially when they renovate old warehouses or just that look. Now they want to see the mechanicals, and you got offices and cubicles below. So what we do is we have the client send us the fan powered FP VAV, fan powered VAV box drawings. And then what we do is we convert that into CAD, and then we lay out our barrier with sandwich between two layers of quilt, our KNC 100 BQQ product, which is going to block as well as absorb sound. We lay that all out so it can be wrapped and then connected with grommets. And then we make what we call a blank in the factory. And in the factory, a blank is like a 4x8 piece of this curtain material. We put it in the water jet, cut it to size through our DXF CAD drawings, measure, sew it all up, put the grommets in, you install it. It all comes together piecemeal. You install it, and away you are. And now it controls the noise breaking out of that fan powered casing. It's a beautiful thing. We also do silencers that can mate up to those as well. Good question.
Sounds super cool. Thank you for answering. Next question. Can you discuss the use of acoustic sound traps in ductwork and construction of same?
Oh yeah, so we touched on that just a little bit, but not a lot. So anytime you have a duct system, you're going to have some prime mover, some fan, some either rooftop air handling unit or an air handling unit within a building. And as that air is pushed into the conditioned space down through the duct system, the duct system works itself like it'll propagate sound from the fan to the conditioned space, like your office or a library, a section of a library or an operating theater or something like that. And we want to keep that noise from the fan, the RTU or AHU, from getting into that conditioned space. So what we do is we look at the fan sound power levels for the supply side to start with, and we look at the duct shape and the proper placement of should we put. It's always best to put silencing close to the noisemaker, but sometimes you can't due to space restrictions. So we got to go downstream of the system on a supply side. And by doing that, we then have thousands of models of rectangular, round, straight, and elbow silencers. And we can balance the back pressure of the external static of the fan and make sure that air gets past there and it quiets down. And we can do that in all, like I said, an operating theater for clean room applications. We can do it for general classroom, library, what have you. We can do it for outdoors, but we want to make sure that sound doesn't propagate through. But we also have to look at the return side of the fan, because since we're not running at Mach speeds of air, we're just running at normal air speeds in feet per minute, that we want to look at the return air side of the fan too. In other words, sound doesn't care which way the air flows. It's going to propagate in all directions. So we've had a lot of people that They'll have a critical space and they'll say, we took all this time and effort to design the supply side and everything's beautiful, but we still have noise in here. And that's because they never looked at the return side of the fan that's servicing the same space. So silencers are basically, you want to look at pressure drop, you want to look at dimensions. They're all made to fit the duct. We don't do standard cross-section sizes anymore. It's whatever it fits the system, making it easier to install. Everything's independently tested, backed by independent tests per ASTM E477. And that's what we do. Yeah. So I don't know if that answers it. It's a big question. I just tried to shorten the answer.
That answers it. Thank you so much. Next question. Which is preferred? Double stud construction with airspace and bat insulation, or a larger stud wall with bat insulation?
So I have to think about that because there's a lot of variables in that question. And so let's simplify it down, because we can take out, let's not care about what kind of wall structure, like if there's gypsum board or let's not worry about that. Let's back out the insulation altogether. Let's back that out. And now we just have a stud wall with, some gypsum board on it. And if we look at that, if you actually have studs, let's say on 16-inch centers, single studs, not then you're going to actually have a lower STC sound transmission class than if you would have the same wall with staggered studs. Okay. And I don't have a drawing here, but basically that's the case. Staggered would be better than a single studded wall. However, it doesn't completely answer the question, because the question said, what about making the wall bigger? But I have a book here, actually. I have it here, and we keep it in the office. It's kind of funny. I just reach for it, right? And really, we keep it in the office, and there's a book here. It says Catalog of STC Ratings for Wall and Floor Ceiling Assemblies. And it's really interesting. It's a free one you can find online. A lot of people republish this. It's a free one, this particular one. This one's from the California Department of Health Services. But in here, I kid you not, there are over 120 different studded wall construction types, and what their STC, their sound transmission class is. The higher the number, the more noise it blocks. So I tried to tame that question down. I probably didn't answer it perfect. If somebody wants to send me a little more detail, we can email them an answer.
Perfect. Thank you so much. I love that you had that book on standby.
Yeah, well, we use it often. It's a loaded question. Not a loaded question. I don't mean anything bad by the person asking it, but it's a
No,
loaded
of course
question.
not. Well, I appreciate you answering it. Next question. How do you reduce HVAC noise from supply diffuser vents located at the floor of an event center concert assembly room for 250 people?
Okay, so let's look at this. This is kind of a great question. This is a great question regardless, but I'm going to say it's kind of a great question because you can relate it to anything. This was related to a theater? I think it was related to an entertainment space or something. Is that what it said? What?
Event center for a
Event center.
concert.
Okay.
Yeah.
So they're in an event center for a concert, and you have all these people sitting in these seats, and all the registers for the cool air say we're in a beautiful climate and we need to cool it off in there. And there's a lot of bodies making heat just because there's too many people in there, but below fire code. So anyway, we got to cool it off, and there's all that air handling noise. We talked about that air handling unit noise, and we want to control that. Well, we can do that in a couple different ways. A lot of times what people will do, if we're just talking about air noise, two things we have to do. Noise can come from the fans themselves, which is the big energy. Let's talk about that. I'm going to separate the fact and assume that there's not too much air coming past the registers, because if you have high velocity air through the registers, now it makes noise when that air is hitting your ankle and your ears, and you can't do anything about that at that point because it's too close to you. You have to put absorption in the space. But if we look at silencers, we would put silencers either at the air handling unit, at the discharge and return of the air handling unit, or if it's a common plenum below for supply, we may put silencers at similar to each of the returns. Of course, it'll be cheaper because there's only one hookup to the air handling supply, whereas there's a bunch of these registers. So silencers would be the thing. And silencers can be used in return and supply air, both forward and reverse airflow. Now let's back that into a data center. Data center has a condensing unit, a crack unit within the server space. They're on a raised floor. That raised floor, the crack unit takes hot air at the top, pushes it down through the unit, cools it off, pushes it under the raised floor. And a lot of times the floors are raised 42 inches tall. And then that cool air comes up through these registers. Well, what would we do there instead of controlling the noise right at that register? We could put a bunch of silencers in. I mean, we could do it at every register, put a little scoop at the bottom of each one for that open plenum return underneath, or at open plenum supply space underneath. Or we would use two things. Kinetics isolated curve to isolate the crack units themselves. Remember, vibration is the enemy of data centers. But then we'd also put a silencer scoop in the bottom of that crack unit discharge and quiet all that fan noise down right there. That's it.
Thank you so much for answering. Just before we move on to the live questions, can you repeat the title of the book you were referring to?
Oh, I don't know if I should, but I did find it free. I did find it free, but the title was Catalog of STC, which stands for Sound Transmission Class. Catalog of STC and, oh no, just Catalog of STC for wall and floor ceiling assemblies. So it's sound transmission class for wall and floor / ceiling, that is floor and or ceiling assemblies. That's what you'd want to search online. And
Sounds
NIH, all kinds of people have this, but you might be able to find a free one online because I think there's a lot of public information. Then there's a lot of non-public information too. I know for us, we do a lot of our own research, which we don't share. It's proprietary, but this is like the 101 book. It's beautiful.
Amazing. Thank you. It sounds like an excellent resource. So just wanted to get that out there. Thank you. Now moving to the live questions. For noise block panels in interior application, what is the allowable height for, it says span table for allowable height before needing additional structural elements.
Oh, this is good. So let's rephrase this and just clarify to everybody. The question was, it made a comment indoors. It said indoors. So my answer would be different if it was outdoors, where we had to worry about the wind forces and size. Well, not seismics, that's minor, but the wind forces. Seismic's important, but wind's typically governing. So this is an outdoors. So my comment here for indoors would be, there's two ways we can mount our panels. We would go 12 feet unsupported. The panels would be, the joints between the tongue and groove panel joints between panels would be vertical. The wall length would be limited to about, any straight wall section would be limited to about 40 feet. And so that's how we'd look at it. Every project would be a little different because it'll depend on if you have doors and different things in there. If you have doors, you might have to support. But if we go taller than 12 feet, now we're going to run the panels horizontal, and we're going to start using, let's say, a 20-foot wall within a building, within a factory. We're going to start using our W columns or HSS tube steel to support that. Let's take it a step further. Outdoors, we will typically always use some form of structural support, even for a 6-foot wall. We'll use some form of structural support just because now we're looking at wind forces. And sometimes we're on a roof and sometimes we're on grade. So we got to take all that into account. Sometimes it's coastal. Sometimes the wind forces are huge, especially coastal, the new codes, IBC codes, which went up considerably for certain coastal areas around the world. But we would use steel outside. But for kinetics, we have successfully freestanding. Now think of freestanding. Freestanding means there's none of those kickers. Remember I talked about those braces, those knee braces are kickers. We can do a freestanding without that up to 40 feet tall on grade. We have the abilities to manufacture, and we have the abilities to design, and we have success in that around the country and world. Yeah.
Amazing. Thank you so much. Next question regarding sound isolation between tenants, wall isolation, top and bottom. That's the question.
Ask that one more time. I'm sorry, it was my fault.
No worries. So it's sound isolation between tenants, wall insulation, top and bottom.
Oh, yes, yes. So Kinetics, it was important because Kinetics has many different divisions within our company, and one of them is called not room acoustics, building acoustics, which picture a multifamily, a apartment complex, government building, or anything. Or school, church, worship space, where we want to control the noise from one room breaking into another. Now, of course, my voice is deep, it's loud, and you might need a little more noise control than others. But what we want to do is we want to almost float that wall is probably the easiest way to say it. If you look at a wall between my office and my colleague's office next to mine, there's a vertical wall here. It's about 14 feet long and about 8 foot tall. And I don't want him or she to hear me. And I definitely don't want to hear her when she's on a phone call and interrupt what I'm doing. So when they designed such a building, they would look at both putting a floating isolation base at that wall at the bottom and one at the top. And those could be typically not spring mounted unless you float the floor, but they would be a lot of times pre-compressed fiberglass pads, Kinetics kit pad. I'm very simplifying this, okay, because we have a lot of different products. So I'm taking the most simplistic that we actually make proprietary that can isolate that much better than neoprene and things like that, although neoprene's an option. Kit pads isolate over them are much more forgiving, and you don't have to know exactly the frequencies you want to control. You have a much wider space of noise control with a kit pad. That's KIP, Kinetics Isolation Pad. And that's one way. Another way we can do it is we actually float the drywall when we mount it to before we mount it to the studs. We actually mount the rails with our Isamax clips that actually float. They're like rubber clips, and your wall basically on furring strips floats in place. So there's a lot of things we can do to control noise from one end to the other. I don't know if that doesn't specifically answer the question. It gets a little more in the weeds, but it tells you that we got what you need. Let's talk.
Thank you so much. Next question. What about the use of vibration isolator to control structure-borne noise?
So structure-borne noise, we have a whole division. In fact, Kinetics was founded on the idea of vibration isolation. And that's where we were. That was our claim to fame for many years until we became we were all structure borne. It was huge. And a lot of structure borne, not just for mechanical equipment, but also precision isolation, like electron microscopes and coordinate measuring machines, and where you have these, 1 hertz, 1.5 hertz cutoff frequencies, really low, really cool stuff. And it's still cool stuff. But then we branched out into any mechanical equipment within a building. In other words, the other day I was in a building and it was driving me crazy. That's a problem when you get into this business. It was driving me nuts because I'm sitting in a waiting room, and all I kept hearing was the air handler or the pumps. I'm sorry, the pumps kick on and off in the mechanical room. The mechanical room was actually about 8 offices down from where I was at, 8 areas down from where I was at. But I heard it kept kicking on, and it was because somebody didn't vibration isolate those pumps and the thrust and also the vibration of the pumps and the motors. And so Kinetics has many different pads, many different vibration isolation springs, whether you're hanging a product like a fan or you're mounting it on the floor or the wall. We look at even track bed isolation when you're looking at subways going next, and they're building a subway next to a building, and you don't want to feel the vibrations of the subway into the building. We even go to that extent. But we have all kinds of vibration isolation, wind restraint, seismic's huge. We look at all kind of seismic restraints. So we'll have spring vibration isolators and pad vibration isolators that also have seismic restraint built right into them. So you're kind of addressing two issues. You are addressing two issues with one product. So we're big into that. We got a whole division of that. It's for years it was the Gorilla division of Kinetics. Now that we got into airborne noise and other things, we basically have a very well-rounded company for many years now.
Great. Thank you so much for answering. That's so fascinating to know that that was the first division for Kinetics structure-borne noise. Next question. What is the most effective way to reduce noise transfer from a rooftop HVAC unit directly above a conference room with suspended acoustic ceilings? And more details, a ducted HVAC system assumes startup noise, air movement noise.
You know, I really love that application. I got a lot of colleagues here that like that too, because if you can solve that, which we can, you really know what you're doing. And it's not just knowing what you're doing, it's knowing what the client needs. And this is really, really neat. This is where our divisions at Kinetics work together. So I'm the airborne guy, right? My group is the airborne people for Kinetics, and at least for mechanical equipment noise. And we were talking about those duct silencers, and we were talking about those noise block panels. Well, we can take those if you have a rooftop unit, an RTU, you have a supply and return opening, and they're both generating noise, and they're propagating down the duct systems. And those happen to go through the roof line because they're up on the roof. And so what we do is we address the silencers for the return and supply, and we address any noise breaking down from the bottom of the RTU through the roof line. And we can do that by adding mass in there by using our noise block panels, laying them flat. And then, oh, wait a minute, we have the vibration isolation because, like I said before, I don't want to hear that RTU or that pump kick on and off when I'm in a waiting room or in a library or something or a worship space. So we're going to vibration isolate and structure borne isolate that rooftop unit. So it's going to sit on a vibration isolation curve that isn't just wind controls wind restraint. It also does vibration isolation. It also controls seismic restraint if it needs, if that's a seismic region of the country. And then you have the silencers in the duct system, and you have the floor panels to block the noise breaking through. So we addressed all the circuits of noise, whether it's airborne noise, transmission loss through the building roof, whether it's vibration, we address them all. And it's in a product actually called an ESSR or a KSCR, which are both vibration isolation curves with sound insulating packages in them. It's really cool. It's a lot of fun. Some people ask us to do some weird things, but that's what we do, meaning that sometimes they want them to get quite tall. Sometimes you got to worry about, oh, well, wait a minute, we can get a curb, instead of 2 foot tall, we can make it 4 foot tall. But, oh, wait a minute, there's a height restriction on the equipment in the first place. So we work with everybody on that. It's a beautiful product, beautiful service.
Thank you so much for answering. Next question. What are your thoughts on ceiling tiles that are acoustic? Can they function alone, or would they need other applications as well?
So if you look at the drop ceiling in many of our offices, right? Drop ceiling in our offices, there's going to be mechanical, like the fan powered boxes above there that we talked about earlier about putting those wraps on. There's also a floor above, and sometimes you can hear noise through that floor. So if we look at just noise propagating down from the floor above and the mechanical equipment above the drop ceiling, the ceiling tile that you see in your office here that has all the little dots, or it has patterns in it, it's usually white. And usually in many buildings, you see a little stain in the corner because there was a leak in the roof. Anyway, you know what I'm talking about. So we have that. So now Kinetics actually has those that has a backer on it. And so instead of the normal mass where you need mass to block sound, these are really just meant to reduce reverberant noise. But when you want to block the sound coming from above these tiles and still have the sound absorption within the space, we have a solid backer that we put on the back of those, and those can be used. You just have to relook at your grid to make sure it can support the weight. But the other thing is there's a short circuit there still. There's a short circuit such as your lights. So you have your lights here, and you have your return air diffusers, where sometimes the return air diffusers just open into, they're not ducted, they just open into a space above. So we have products at Kinetics that can isolate noise breaking through your light system, your lights within your track, and your suspension system. And then also we have silencers and scoops that can specifically go on your return air grills for the open returns above the drop ceilings. Once again, these are great questions, folks. I don't know who's asking them, but I really appreciate it because I keep coming back to the same thing. Oh my God, Kinetics has this too. And this is how our markets pair together. Yep. To bring all these products together with expertise, not just a bill of goods, but expertise.
That's amazing. Thank you so much for answering. Next question. What is the 8-hour time-weighted average noise level set by OSHA that requires the implementation of a hearing conservation program?
Typically, we've been looking for years. It's been 85 dBA, 85 dBA. Anytime you're over 85 dBA on a time weighted average, you have to start looking at hearing conservation program. People have to look at PPE. And potentially, that's the first thing to grab for is PPE, is the personal protection equipment, such as the good old earplugs or muffs, ear muffs. But a better way would be to control using engineered controls, where you quiet down the noise at its source, so people don't have to wear hearing protection. Another one is maybe move those people around, an administrative thing, move them around so not everybody works in that space. They're not exposed 8 hours. They're exposed over 85 dBA, but maybe for just a few 1 or 2 hours. And there's all those areas. But I think the key thing is 85 dBA. For years, they've been talking that it's going to change to 80 dBA. It never has in 35 years of my career. Although a lot of clients will, instead of try to meet the 85, they'll say, let's shoot for 80 dBA or 75, depending what's reasonable cost versus noise reduction, and go that route.
Perfect. Thank you so much. And the last question I can take here is, how about the use of heavy landscaping around data centers to absorb noise?
No, heavy landscaping can work. It can work. In some cases, it can work. I think you have to look at in the landscaping, how tall does it need to be if you put in a berm, a big hill, a berm of dirt? If you put in things like pine trees or fast growing shrubs and things, how long will it take them to get to the height you need them to get to? Will you have to continue to service them over time as they get older? Do you have to take care of them? Do you have to replace them? They definitely look great. I mean, I'm a garden guy. I love that landscaping and gardening, but what we find is they will help you. But what happens in the winter? Let's say you put up a bunch of trees, and oh my gosh, you thought you planted a bunch of these pine trees that would protect you all year round with noise because they'd have the needles on them all year round. And oh my goodness, we got 1,000 feet of these pine trees and over $1 million of pine trees. We planted them, and guess what? They're the kind of pine trees that lose their needles in the winter. Oh crud. Well, we don't worry about noise in the winter. Yeah, we do. Some areas it's not cold, people are outside. So it is nice to use landscaping. I think the definitive way to do it is to use a noise control product such as a wall system or something like that. The wall systems, to remember too, what we see a lot of times is they'll put up a wall. Although they're not true security walls, you can also add some security because of them. You can also paint them any color. You can even put company logos on them. It's really cool. You can alternate panel colors, and then you can put landscaping around them in certain areas. So I think overall they're a longer lasting, tried and true, and they're backed by independent testing. You know exactly what kind of noise control you're going to get.
Amazing. Thank you so much for answering all the questions. That was all the time we had. And thank you so much, John, for your excellent presentation as well. Thank you to everyone who joined us today. If you need to reach out with any additional questions, John's contact information is currently up on the screen. Just a reminder, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey, as it helps us to continue to serve your needs in the future. On behalf of the Construction Specifier and Kinetics Noise Control, thank you again for joining us, and enjoy the rest of your day.
Thanks, folks.